Hello everyone, welcome to the SQRT channel. In this video, we are going to talk about a very interesting problem from a Stanford Math Tournament from 2021. In this problem, we have log of x in base y plus log of z in base y plus log of x in base z is equal to 8. On the other hand, and for the second equation, we have log of z in base x plus log of y in base z plus log of x in base y is equal to 25 over 2. We also have another condition. We know x is greater than 1, y is greater than x, and z is greater than y. With all these, we want to find log of x in base z. Before moving forward to talk about the solution, make sure that you pause the video to think about this problem. To solve this problem, we are going to start with using some new notations. We are going to use a for log of y in base x, b for log of z in base y, and c for log of x in base z. With the new notation that we have for a, b, and c, if we multiply a by b by c, you can see that the answer is going to be 1 because of the chain rule that we have here. Now let's go back and see what we had. With the new notation that we have for a, b, and c, we can say that we have three equations now. We have ABC is equal to 1, we have a plus b plus c is equal to 8, and we have 1 over a plus 1 over b plus 1 over c is equal to 25 over 2. For the last equation, note that what we have, for example for a, is log of y in base x. However, in this new equation that we have, instead of log of y in base x, we have log of x in base y. So instead of using a, we just used 1 over a. Now let's move forward and simplify the last equation that we had a little bit further. First of all, we have 1 over a plus 1 over b plus 1 over c is equal to 25 over 2. If we want to simplify it, we can say that we have a, b, c for the denominator on the left hand side, and then we have ab for the first term, ac for the second term, and bc for the last term. At the end, we have ab plus ac plus bc over abc is equal to 25 over 2. Remember, abc is equal to 1, so we can simplify the whole expression and write it as ab plus ac plus bc is equal to 25 over 2. Before moving forward to talk about the rest of the solution, let's remember something from the past. We have VITA formula. When we have a cubic polynomial like px, which is equal to ax to the power of 3 plus bx to the power of 2 plus cx plus d, we know if r1, r2, and r3 are the roots of this polynomial, then we should have three equations that we need to satisfy them. The first one is r1 plus r2 plus r3 is equal to minus b over a. The second one is r1 r2 plus r1 r3 plus r2 r3 is equal to c over a. And the last one is r1 times r2 times r3 is equal to negative d over a. We are going to benefit from this VITA formula in the next part of the solution. To do this, we are going to remember that we have a, b, c is equal to 1. We have a plus b plus c is equal to 8, and we have ab plus ac plus bc is equal to 25 over 2. So we can say that if we construct a polynomial and we say a, b, and c are the roots of this cubical polynomial, then we need to have three equations to satisfy. The first equation is the multiplication of all the roots should be negative d over a. First of all, we know the multiplication of the roots, or ABC, that we have here is 1. And we are not going to use any coefficient for the t to the power of 3 here. So we are going to use a is equal to 1. Since ABC is equal to 1, then d needs to be negative 1 to satisfy the multiplications of the root is equal to negative d over a. The second equation that we are going to consider is sum of the roots should be negative b over a. We used 1 for a, so sum of the roots should be negative b. We know sum of the roots here is 8, so b is going to be negative 8. For the last one, we know that sum of multiplications of each two roots should be equal to c over a. A is equal to 1, so c should be equal to 25 over 2. Based on a, b, c, and d values that we found, we are going to construct a cubic polynomial here. Basically, we will have p of t is equal to t to the power of 3 minus 8t to the power of 2 plus 25 over 2 times t minus 1. And a, b, and c are going to be the roots of this polynomial. Now we have a cube polynomial and we need to solve it. Basically, the polynomial that we have is t to the power of 3 minus 8 t squared plus 25t over 2 minus 1. To solve this polynomial, we are going to use the rational root theorem. Remember, when we have a polynomial of degree n with an as the leading coefficient and a0 as the constant term, to have a rational solution x is equal to p over q when p and q are relatively prime, we are going to satisfy two conditions. The first one says p should be an integer factor of the constant terms a0, and the second one is q should be an integer factor of the leading coefficient an. Also note that the polynomial that we have should have integer coefficients. ai belongs to the integer numbers, and a0 and a1 should not be equal to 0. In the equation that we have here, we have 25 over t. In the equation that we have here, we have 25 over 2, which is not an integer coefficient. To change that to an integer coefficient, we are going to multiply everything by 2. It doesn't affect the roots that we have here. So at the end, we have 3 to the power of 3 minus 16t to the power of 2 plus 25 minus 2. Now we are going to find the roots of this polynomial. So we are going to look for p over q, where p and q are going to be relatively prime. P is going to be a divisor for negative 2, and q is going to be a divisor for 2. Based on what we've learned, 2 can be a potential root for this polynomial. 1 can also be another potential root. We need to basically try and see if one of these values are going to be a root for this polynomial. If you try them, you're going to see 2 is actually a root for this polynomial. And then you can verify that the other polynomial that you are going to extract after factoring t minus 2 from this polynomial is going to be t squared minus 6t plus 1 over 2. For the polynomial with degree 2, which is t squared minus 6t plus 1 over 2 is equal to 0, we can use the traditional approach and find the roots. They are going to be 6 plus minus SQRT root of 34 over 2. So at the end we have 2, 6 plus SQRT root of 34 over 2 and 6 minus SQRT root of 34 over 2 as the roots of the polynomial. Now let's go back to the original problem that we wanted to solve. We have it here. We wanted to find log of x in base z. And if you verify, you can see that log of x in base z is basically the c value that we wanted to find. We showed that a, b, and c are the roots of the polynomial that we had. So one of these values are going to be c. In other words, it can be 2, it can be 6 plus SQRT root of 34 over 2, or it can be 6 minus SQRT root of 34 over 2. We are going to find out which one is the case here. To do this, let's use the condition that we have in the problem. We know x is greater than 1, y is greater than x, and z is greater than y. Since x is less than y here, we can say that log of y in base x is going to be greater than 1. We also have log of z in base y. Log of z in base y is also greater than 1, since y is less than z. On the other hand, x is less than z, so log of x in base z is going to be less than 1. From the three roots that we have here, one of them is going to be less than 1, and that's 6 minus SQRT root of 34 over 2. The other two are greater than 1. In the problem, it asks us to find log of x in base z, which is the one that is less than 1. So at the end, 6 minus SQRT root of 34 over 2 is the final answer that we need to find, and that ends our solution. Thanks for watching the video. If you would like to see more puzzles and math-involved activities, please subscribe to the channel. This is the SQRT channel.